Well, I think what brain imaging has really helped us to do is make an invisible mental injury visible, right? And so in the past, people with mental illness, all their symptoms were invisible. And I think that really contributed to the stigma of mental illness.
You can now visibly see that something is wrong with the brain. And so by mapping out some of the different brain changes and how the networks function differently in psychiatric illness, for example, post-traumatic stress, it's really helped us to get a much better understanding of how the disorder works in the brain, and it's really helped us to think more about how to approach treatment.
Yes, there's very different responses to stress, and I think that also translates into two different types of post-traumatic stress. And what we've shown is that about 70% of people have this presentation where they have too much emotion, right? Too much fear, too much anger, too much shame. They're hyper-aroused, their heart rate increases when they're triggered. But then there's another a subgroup of post-traumatic stress disorder patients that have a very different response. So when they're triggered, they're often very detached from their emotions. They shut down. Their emotions are too overwhelming for them to deal with them. And so I think it's a way the mind copes to really overcome tremendous stress and hyper-emotionality. And so these people detach themselves from their emotions. They're numb, they don't feel anything. Often they have out-of-body responses. They feel like they're disconnected from their own body, and the world feels like it's unreal for them.
Now we're learning that the brain stem, so the old reptilian brain, is very affected in post-traumatic stress because that is sort of deals with innate reflexive alarm responses. And so I think what that teaches us is to think about how can we target that part of the brain directly with different treatment strategies.